config list, we see that it's set up for 2 through 5. And if we connect to the remote system, the 100 box, let's find a free shell here to be able to connect to it. We'll Control-Shift-T to open a new one. Then SSH to 168.75.100. And since it's a SUSE box, we'll RC DHCPD stop. This will stop the instance. And then we'll be able to start our instance locally. Let's go ahead locally and find a root shell. We'll execute service DHCPD start. And on the remote system, it's simply RC DHCPD stop. And to set it up when the system boots is check config DHCPD on. This sets it up in 2, 3, 4, and 5. So let's return to the shell, start DHCPD locally, and barring no configuration errors, it should start as expected. And again, in var lib DHCP version, or for D for version 4, we'll find a leases file. This leases file will contain any leases issued, and we'll take a look at the less using the less command DHCPD leases, and in here we'll find entries for leases. Now supposing we don't want to alter the current configuration on the network, we can set up a reservation. For example, for this remote system, this 199 box, let's execute ifconfig. And it's not in our path, so we'll sbin ifconfig. We see that it has an address of 199. So our next task is to set a reservation. Set up DHCP reservation, which is a common task. And this requires the MAC address. So it requires the MAC address of the client. And it also requires that we indicate which IP address is to be reserved for the remote system. Remote system's MAC address is the hardware address returned using ifconfig. Take this address and build a reservation. So let's return to the shell to the config file on the local system. And there is a commented reservation section, and the host is called Linux CBT Serve 4. This is just a descriptive name. The host name that's associated with it can be defined independently between the host blocks, or in between the host block. We need to at least uncomment hardware Ethernet address as well as fixed address, and then paste in the address, ensuring that the line terminates with a semicolon. The fixed address needs to be set to an address that the server is authorized to lease, 192.168.75.199, and the next dash server is unimportant. So we have a reservation that DHCP will honor. Whenever this MAC address comes in with the DORA request, it will be assigned this fixed address. We may optionally pass in options that are defined within the subnet block between the host block, such as a host name option, using option space host dash name space and in between quotes the name of the host. That host will be assigned, or the name will be assigned to the server if DHCP is allowed to configure the host name. But again, the prerequisites include the hardware Ethernet address and the mapped fixed address. So it requires a MAC address, requires the fixed address, which is basically the IPv4 address to map to the MAC address or to the client. The rest are optional. So see, optional options are supported between host block. So that takes care of reservation. But whenever you make a change to, or changes to the primary config file, one, you need to save it. Two, you need to restart the DHCP server. So, service DHCPD restart. Restart to effect changes. And once we've done that, if all goes well, barring no configuration errors, the DHCP server will be up, running, and listening for requests from a specific host, as well as for requests from other hosts on the wire. But in particular, it will listen for and map requests from the specific host with a MAC address indicated by the reservation. This is the reservation block. When it finds this MAC address in the query, it will assign this fixed address, and expect to see the messages in var log messages. You'll find the whole DORA process here. You can watch it using tail while you restart a remote system. So for example, let's watch tail var log messages. This will continue to run as entries are added. And in a separate window, if we SSH as root over to the remote system for which we've set up a reservation, and then restart its DHCP service, or its networking service, that is. So in etc initd, we've got a network service. We can indicate that we'd like to have this service restarted, so service network restart. This will kick us off and restart the interface, and what will happen is a DORA request will be made to the DHCP server. So let's pause here to take a quick look at this interface. Pausing the screen, we mean. Here's a request. Here's an acknowledgement. Request for 192.168.75.199. So we look at the whole correspondence, and for 1034, which is where it began, remove host declaration, or remove 192.168.75.199. And from the dynamic address pool, .199 has been assigned. Here's a request for 199 from a given MAC address on ETH0. Here's an acknowledgement, which is the acceptance stage, the last stage. And that's the full process. So we're able to look at the DORA process, and we'll relabel DORA the last step, acceptance / acknowledgement, or acknowledgement. Relabel it as acknowledgement / acceptance. That's where the acknowledgement occurs, and we'll see the changes in var log messages. Now, how do we know indeed that our DHCP server has leased the address to the client? Well, we can consult the leases file. And let's do so on the client. And we still have an SSH session. Let's navigate. We should also note that the client also maintains a DHCP client directory which contains a leases file. If we list the contents of DH client interface.lease or leases, we'll see what we're looking for. Let's scroll down and we'll see that the lease originally came from the .100 system with various settings related to time, but now the leases come from the .10 box. This is the DHCP server identifier. The address is fixed. Here's a subnet, offset, EST timing, default gateway, lease time, DHCP message type, domain name servers, NTP servers, domain name, when the address should be renewed by, or when it was renewed, we should say, as well as rebound and expires. So when we should rebind the address at 2049 tonight, and when it expires at 2134. So at 1753 today, we will attempt to renew, not have renewed, but we'll attempt to renew at 1753. We'll try to ensure that we have the address fully by 2049, and by 2134, if none of the recent entries have worked, then we would have lost the address. But here's the most recent entry, proving that we've gotten the address from the appropriate server. So our server's up and running, and we can tweak the entries as we see fit and just grow the dhcpd.conf file to suit our needs. Primarily, you're going to place directives beneath or between the subnet block. But you'll also place some of the directives outside of the subnet block, such as NTP servers. Usually NTP servers are shared by clients across subnets within your environment. So we've got DHCPD up and running. Again, no SE Linux implications. And importantly, check config. DHCPD tells us it'll start in the multi-user run level, so when the system reboots, it'll come up. It's disabled on a remote system. We've configured at least one DHCP reservation, and we now know how to set up a subnet block with some options for time as well as domain and other directives. So let's continue our study of Red Hat Enterprise Linux in subsequent sections.